Next two lessons kind of go together. We start talking about scale models and then we use indirect measurement. So in both of these situations, we're going to use proportions to set up and solve to be able to find missing values, just like we have before. So on a blueprint, the basement is 4 inches long by 3 inches wide. The scale is 1/2 inch equals 8 feet. Find the missing dimensions. So let's do the length first, and then we'll go back and do the width. So first thing to do is to start off with your scale. That works kind of like a conversion for us when we were talking about converting with measurements. So I'm actually going to start off with 1/2 inch over 8 feet, which is equal to, we're now looking at the length, so 4 inches. Inches over feet, inches over feet. 4 inches would go on the top with inches, and we're trying to figure out how many x feet that is. Heart method here. So 1/2 x equals 8 times 4 is 32. This is a fraction here, so we're going to multiply by the reciprocal, which is 2 over 1, or just 2. And we get x equals 64 feet long. I know my label is feet because the x was with feet. Go back, do the same thing with the width. The scale is still 1/2 inch, is 8 feet. So inches over feet. My width is 3 inches. We're trying to figure out how many x feet that is. So by the Hart method, 1/2 x equals 24. We're going to multiply by the reciprocal again. So x equals 48 feet wide. Number 2. Carpenter wants to build a desk like the 10.5-inch one his daughter has for her dolls. Here's the size of hers. The scale he's using is 3.5 inches to 1 foot. What would be the height of the life-size desk? So here's our scale. Use that to set up the first side of your proportion. 3.5 inches over 1 foot. Inches over feet, inches over feet. In the problem, the 10.5-inch one, that goes with inches. We're trying to find out x feet in real life. Hart method, we get 3.5x equals 10.5. So go ahead, you're going to divide by 3.5 on both sides. X equals 3 feet tall in real life. The next example, a tennis court is 36 feet wide. The drawing of the court is 2 1/4 inches long and 1 inch wide. So here's our picture. So we have our tennis court. It is 36 feet wide, so let's put that there. And we have a drawing of the court, which is going to be smaller, and that's 2 1/4 inches long and 1 inch wide. So if you notice, these are in the same spot. So our scale is 1 inch in the picture is to 36 feet in real life. So if we need to find the length of the real court, x, 1 inch to 36 feet equals inches over feet. Inches we have, x feet is what we're trying to find. So x equals 36 times 2 1/4. It's going to give me 81. So it's going to be 81 feet long in real life. In the next part, it talks about model trains a little bit. There's different size model trains. The O scale is 1 to 48. The village below was created to look like a real town, and what they do with model trains is they actually model the sizes of the items as well to be on this scale. So the post office is 12 feet tall. How tall is the model in inches? So if it's 1 to 48, so this is my model, and this is my real life. So if it's 1 in the model, it's 48 in real life. The post office is 12 feet tall, and we want to know how tall is the model then. So the post office is 12 feet in real life, and we want to know the model. So 12 times 1 is 12 equals 48x. So we're going to divide by 48 to get x alone. And 12 divided by 48 is actually going to be 1/4. So in our model, it's going to be 1/4 of a foot tall. But this said in inches, how much is that? So inches would mean 1/4 of 12 inches, which is really 3 inches tall. Here's another one for you. On the map, the distance from Seattle to New York is 8 inches. How far is the distance in miles? So down here, 1 inch is 557 miles. So we know inches over miles. 8 inches is going to go up top. That's x miles in real life. So we're going to get x equals 557 times 8, which is 4,456 miles. We can actually continue on with the last couple examples here that uses similarity and indirect measurement. So indirect measurement basically means that you use an item you know the height of, or you know all the measurements of, to calculate an unknown. So in our case, what we're going to end up using is we're going to use objects' height compared to their shadows. So a school that's 40 feet high casts a 160-foot shadow. The nearby cell phone tower casts a 210-foot shadow, but we need to know the height of the tower. So I recommend that you always do height over shadow, or you can do shadow over height, whichever way you pick, you got to stay with it. So 40 feet high is the school, and that casts a 160-foot shadow. I usually put an S there. So feet, and this is my shadow. So the cell tower casts a 210-foot shadow, so that goes there. We want to know how tall it is. So if we go ahead and multiply through the heart method, and we're going to go ahead and divide by 160 on both sides, and we get 5.25 equals x then. I missed a 0. That would be y. So we actually get 52.5. My apologies. So our tower is 52.5 feet tall. And the next one, a fire tower casts a shadow 30 feet long. So here's your picture of this, 30 feet long. A nearby tree casts a shadow that's 8 feet long. How tall is the fire tower? For here is x. If the tree is 20 feet tall. So 8 goes to 30. And 20 goes to x. So x times 8 is 8x. And this gives us 600. So divide by 8. And that gives you 75 feet